Hi there, Nate Gibson here. This is my video for Mod 4, and for my beautiful problem, we'll get right into it with the standard at hand. The standard we'll be talking about will be FLE from the Mathematics Common Core State Standard from Washington, dealing with linear, quadratic, and exponential models. So the standard is construct and compare linear, quadratic, and exponential models and solve problems. You can see the specifics there lined up. Basically, the standard is dealing with it requires students to be able to create all three of these different types of models and then compare them with each other. And so once we get into our beautiful problem, we're going to be seeing that's exactly what we're going to be doing with the problem. So as far as what information students should already know, this problem is probably would be something that would come from maybe an Algebra 2 type class. And so students would already certainly have exposure to linear equations as well as graphs, and as well as a lot of exposure with quadratic equations and graphs. And exponential equations coming a little bit later than the first two. This might be something we just covered in class, and now that we've covered all three, we have a chance to compare them all. So as far as the actual beautiful problem, if I can pull it up here, the problem is this. The population of humans in the world reached 2 billion in 1927. It then reached 3 billion in 1960. By 1987, the number of people on Earth was up to 5 billion. And in 2011, the world population reached 7 billion. Using strategies we have covered in class, create three equations which model the world population over time. One equation should be linear, the second should be quadratic, and the third should be exponential. For each of the three equations, discuss whether the equation makes sense for modeling population growth. After you discuss all three, argue for which equation makes the most sense as a model for the world population over time. Your explanations of your equation should take up between 1/2 and 1 full page, double space, Times New Roman font. You should also attach your work used to find your three equations. So basically, the problem is set up to be students are given information, and from the information given, they will have strategies that they already learned in class for linear, quadratic, and exponential functions for how to kind of find a function that best fits the points given. So basically, the year would be the independent variable, and the population would be the dependent variable, or the variable put on the y-axis. And so students then are going to find these three equations using the three different types, the three different paired functions, and fitting it to the information given. But then later they're asked to kind of dive in and figure out, well, let's apply this and what actually makes sense here. It's kind of what we know logically about how population grows, but also looking at our data. If you put on a graph, like what shape is this going to make? And so basically, excuse me for a second. As far as is writing the best way to attack this problem, I would say yes for a lot of it. I think as far as solving for the equations, certainly that won't be done through writing. That'll be done through the processes and formulas and things that we've gone over in class going into this, and kind of plugging in numbers and figure things out as far as the variables go. Once we have those equations, I think writing is very beneficial for this problem. I think being able to write and actually express your thinking as a student and saying, you know, this is the answers I got, but then applying that and well, what makes sense here? The whole point of this problem would be that given the same set of information, there's a lot of different conclusions you can come to as far as the pattern that data is taking. And so then being able to critically think and say, you know, I think this makes sense. I don't think this makes as much sense. I think that's an effective use of writing in this context. The operative verbs in this problem would be discuss and argue. And I think discuss is kind of the first step, and that would be just kind of getting your thoughts on the page as far as, you know, this kind of makes sense to me, this doesn't make as much sense to me. And that's important because it's the kind of the first step, as I was saying, about once we have our answers, then that would the discuss piece would be, okay, does this make sense? Does this not make sense? Once we then get to argue, that's where the students are really going to try to be making their point. And as it was made clear in the screencast, and then also in the readings, there's such a stress from the Common Core curriculum about students being able to argue and defend a position. And so this is really the core piece of the writing in this problem, and it would be setting up for students to be able to, to kind of take a stand and say, I think this one makes the most sense. This is this is one of my three equations that really not only fits the data, but logically it would seem that this is a pattern that is emerging and will continue to happen. As far as the importance of being able to argue in math, I think so much of math is anytime anybody makes any advancements in the field, it's to be able to prove that what you've just done is valid. And so that's done obviously through the process of, showing your way through your work and being able to argue, say, you know what, this makes sense, and this is something that does work every time. This is the validity is here. And so it's not as much of an argument as you might see in other fields if you're in an English class or something like that, or if you're in a humanities class and you're trying to argue a position. It's not quite that, but maybe the idea of arguing mathematically would be arguing for the validity of an answer. And again, with this problem, it's not like there's not a complete right and wrong. There are three different stances you could take. You could say your linear, your quadratic, or your exponential function fits best. So being able to argue in that sense would be based on the data given. I think such and such graph is what makes most sense. In the case of this problem, it should be exponential is what is ultimately going to fit the data, and hopefully students come to that conclusion. But again, the problem does set up nicely so students can, even if they're not coming to that answer, they're able to defend their line of thinking, and a teacher that can then get a good grasp of, okay, that's incorrect, but I at least know that's where they're at, and they're trying to make sense of the problem. And just lastly, there's a little bit of the housekeeping stuff getting at the end, and then getting into the rubric, we will see that show up again. So going to the rubric, and this was a rubric that I found online and then adapted to fit, made some changes to fit the specific problem. Basically, it sets up, there's 4 different categories you see in the columns there. So for each category, if a student does an excellent job and completes everything well, above average, above standard, they'll receive the full. It's set at 5 points, 4 points, 3 points, 1 point. Those are really going to be more percentages of the total points given on the far left-hand column. For example, for content development, they would get all 25 of those points. If they just ended up with a good category, they would get basically 4/5 of those 25 points, so they'd end up with 20 points. But the categories going down the left-hand side would be content and development. And so that's really focused. It's partially focused on the writing, but it's also focused on the mathematics behind it. So coming up with 3 equations that fit and are logical and work. The reality is there's a little bit of flexibility with the equations students are coming up with because they have 4 data points, and for a lot of the processes of finding an equation, you're only using 2 or 3 points. And so there's a little bit of flexibility there, but basically for a student to get excellent, the content has to be comprehensive, accurate, persuasive, and well researched. And so basically it has to make their process of coming up with equations has to make sense, and then their writing behind it has to fit. It has to kind of based off the equation they have, what they're saying about those equations has to make sense. Getting into organization and structure, this is more getting into the writing, and so for excellence, it would be the paragraphs are clear and easy to follow. The structure incorporates mathematical formulas. So the incorporation would obviously be taking the equations they came up with and then discussing them. But hopefully students are able to write clearly and concisely and in a way that's easy to track as they explain the work they did and why or why not they think that equation came up with makes sense. The format, that's just making sure that students are using the guidelines given, which weren't terribly complicated, just meeting the distance requirement, or the length requirement on the paper. You can correct font and text size and formatting and all that. So if they meet all that, they'll be an excellent category. And if they fall most of those, they'll be good, even less fair. And if they really struggle to meet those requirements, they'll be poor. Lastly, grammar, punctuation, spelling. Just as was pointed out in the screencast for wow, tongue twister there. As was pointed out in the screencast for the class, this isn't as big of a deal in mathematics as maybe other, but we do still hope that students are turning in quality writing, that they're not just listing fragments or bullet points, but they are engaging and really putting their thoughts down on the paper in a way that is coherent and grammatically correct and all that. So we do have a portion of our rubric set aside for that. Yeah, as far as lastly, anything beyond writing, the thought of having students present on their findings, I think it could be beneficial. The reality is each student is coming up with is dealing with the same problem and should be coming up with a fairly similar solution. And so what I thought might be better than a full class presentation for every student would be to put them in smaller groups and let them discuss what they found, maybe the following day in class or the day it's due. And this may be a very quick process if all the students in the group came up with the same answer, and they might have a lot to talk about. But if students have different viewpoints, that can be a cool thing for students to be able to discuss with each other. So the idea I had would maybe give 5 to 10 minutes for students in groups of 3 or 4 to discuss what they found, and then bring the whole class together and let students share differences they found or similarities and defend their position. And that come back to that whole point of arguing for what you kind of believe is correct as far as the mathematics goes. So that might be something I would implement beyond the writing, but other than that, that is my beautiful problem. Thanks for listening, and you guys have a good week.